Yes, welcome to Trice webinar classes now. So, myself, Rajeshwari Madam, PGT Physical Science from Lingampally. So, today we are going to deal our topic in alkyl halides and aryl halides. This is a small introduction for your EAMCET and NEET program. Yes. So the first question here, which is coming in the alkyl halides is secondary alkyl halide among the following is. What is the secondary alkyl halide? Okay, ma. So let us see here. Yes, here we are having isopropyl chloride. Okay, so isopropyl chloride means how many carbons we will be having, ma? So 3 carbons you are having. Okay. Yes. So here okay, so here in the secondary alkyl halide, so what is the, among all these, which is the secondary alkyl halide? Let us see. So the first example here is isopropyl chloride. So isopropyl chloride means here we are having a 3 carbon compound. Okay, yes, in this 3 carbon, if you are taking one of the CH3 group, CH3, CH and CH3 group is known as isopropyl chloride. So here you can clearly understand that yes, here isopropyl chloride means an alkyl halide which is having 3 carbons with CH3 group, CH and CH3 group and chloride. So it will become a, because if the carbon is attached to 2 other carbons, that is secondary alkyl group. Okay, secondary carbon. So the halide which is attached to the secondary carbon is known as isopropyl chloride. Hence, the first answer will be your answer for your secondary alkyl halide among the following. Okay, ma. So isobutyl means here in this butyl carbon, the carbon is tertiary carbon. That's why the answer will not tally with this. So that's why isobutyl chloride is wrong. And once you look at the second option here, ma, yes, in this second option here, here we are having CH-Br2. So on the same carbon, 2 Brs are there. So I'll write here, ma, CH2. This is CH2 only. Okay, and here we are having Br. Okay, and here also we are having another halide, that is Br. Okay, so on the same carbon, 2 halides are present like this only. So then it is a gem dihalide. So our answer will be the second one. Yes, so our answer is second one. So second one is our right answer. right? So second option is our right answer. This is the right answer. Okay. Why? Because on the same carbon, two halogens are present. So that is a gem dihalide. Gem dihalide means if on the same carbon, two halogens are present means that is gem dihalide. If on the different carbons, here you can see in the first example, on different carbons, two halogens are present. That means adjacent carbons, two halogens are present means those are known as vicinal dihalides. So vicinal dihalides means on the adjacent carbons, if two halogens are present, such type of halides are known as vicinal dihalides. Okay. So our right answer will be the second one. And third also, if you look at, see here, one carbon is having bromine, and here the last carbon in between an alkyl group is chem. So in between alkyl group is there means they will not come under either vicinal or gem dihalide. Okay, ma. Here, yes, this example will come under vicinal dihalide. Okay, ma. So this is also wrong answer because in the question they have asked about gem dihalide. That's why our option is second answer. Okay, second answer is our option, right, ma? Yes. Now next we will go for the third question. What is the third question? Yes. Just now I explained now what is vicinal dihalide. Vicinal dihalide means any carbon, okay, on two adjacent carbons, a halogen should be present. Okay, on two adjacent carbons, if halogens are present, two halogens are present on two adjacent carbons means then it is known as vicinal dihalide. So it is a vicinal dihalide. So let us see what is the answer. See here, on this carbon, no halogen. On the second carbon, only one halogen is there. So we want two halogens because in the name only it is there di. So we want two halogens. Here only one is there. So this will be wrong. Now look at second one. Where is our second one? Okay. Yes. Here we can see the second option. In the second option, see here, in the second option, here we are having bromines on the same carbon. So that means it is an example for gem dihalide. So our question is not on gem dihalide, it is on vicinal dihalide. That's why this is also a wrong answer, right? Then if you look at the third option, only one halogen is present. So here also this is a wrong answer. Then if you go for the fourth question, see here, fourth option. On two adjacent carbons, on first carbon, one bromine, and the second carbon, another bromine. So two halogens are present on the adjacent carbons. That's why it is a vicinal dihalide. So our answer is fourth one, because fourth option we are having two halogens, that is bromine. Both the bromines are present on two adjacent carbons. Hence our answer is 4. Okay, ma. So that is vicinal dihalide. Now let us see the fourth question. What is our fourth question? Yes, our fourth question comes here, ma. So what is that? For the preparation of alkyl halides from the alcohols, which among the following cannot be used? For the preparation of alkyl halides, we will use PX3 and we will use PX5, that is any pentahalogen compounds, trihalogen, phosphorus, and pentahalogen, phosphorus, and we are using SOCl2, that is thionyl chloride. SOCl2 is known as thionyl chloride. So here PCl5 we can use, SOCl2 we can use, PCl3 we can use, but we cannot use NaCl. It is our common salt. Okay, so because this is our common salt, we are not at all using as a catalyst for the preparation of alkyl halides from alcohols. So hence in the question they are asking you which among the following cannot be used. Look at the question carefully. Cannot be used. So cannot be used means, that's why our answer is sodium chloride. So all these are not asked in the question. They are asking which cannot be used. So sodium chloride cannot be used for the preparation of alkyl halides from alcohols. Okay, ma. So that's why our answer will be 4. Okay. Now let us see for the fifth question. What is our fifth question? Right. So our fifth question is Grignard reagent. Grignard reagent means here I am writing ma RMGX. RMGX is known as Grignard reagent. Okay. So Grignard reagent is formed when alkyl halide reacts with which one of the following they are asking you. So here we are taking alkyl halide and they are asking you Grignard reagent is formed. So what is Grignard reagent? We know that is RMGX. So from this alkyl halide, I want RMGX means when I am treating with magnesium in the presence of dry ether, when you are treating alkyl halide with magnesium in the presence of dry ether, we will get Grignard reagent. So which option is suiting for this one? See here, magnesium in alcohol. So this is not correct. Magnesium in acid, not correct. Magnesium in dry ether, yes, this is the right option because alkyl halide reacts with magnesium metal in the presence of dry ether to form our Grignard reagent, that is RMGX. Okay, and MgO, this is also an incorrect answer. So our answer is third one, magnesium in dry ether. Okay, so what is Grignard reagent? RMGX is known as Grignard reagent. Okay, ma. So this is the fifth question. Now let us move on to the sixth question. Yes, in the sixth question, what is the sixth question? See here, when alkyl halide reacts with moist silver oxide, Ag2O is called as silver oxide, it gives us what? So let us try here. So alkyl halide, I am taking Rx. So R means nothing but our alkyl. X is halide and I am treating with moist silver oxide, that is Ag2O. Okay. Whenever you are taking moist condition of silver oxide means I am taking moist here na? So then it will give you compulsorily alcohol. You will get ROH. ROH will be formed alcohol and you will get AgX. So let us write here AgX. Yes, this is our silver salt. Okay. So here, when you are using moist silver oxide, we are getting the alcohol. But there is another condition for alkyl halides. If you are using for same alkyl halide, if you are using silver oxide, that is Ag2O, but we are using, instead of moist condition, we are using dry silver oxide. If you are using means, then it will give us a dry ether. We are not getting alkyl halide, but we are getting here diether. Okay, ROR. So here 2 moles of alkyl halide will participate in this reaction to form diether. Okay, plus our silver salt. Okay, so here in this, in the question they have asked about moist silver oxide. Na? So moist silver oxide. Then what is our answer? Alcohol. So where is our answer in the given options? Yes. So here is our option. So alcohol is our option. So alkene is wrong. Alkane is wrong. Ether. Only the condition is dry ether. Okay, ma. So the condition should be dry. Then only you will get ether. So this is ether. Okay, when we are using dry Ag2O, then only we are getting ether. But here we are using moist silver oxide. That's where we are getting alcohol. So the answer will be alcohol. That's why option is 1 for this question. Yes. Now let's just move on to next question, that is alkyl halide on reacting with zinc in HCl. Yes. Alkyl halide on reacting with zinc in HCl gives what? So let us try here. Alkyl halide Rx. Okay. Then here zinc in HCl is an reducing agent. Okay, ma. Zinc in HCl, it is a reducing agent. So alkyl halide, it will be getting reduced in the presence of zinc HCl. Reducing means addition of hydrogens. Reduction is addition of hydrogens. So here this hydrogen, it will react with alkyl halide to form our alkene RH. Only RH will be formed and remaining one more hydrogen atom is there now. So that one more hydrogen atom, it will form HX. So we got our alkyl halide. So here is our alkane. Okay, we are getting alkane from the alkyl halide on reacting zinc with HCl. So the answer is alkane. So that's why the option is alkane. See here, alkane. This is the right option. We are not getting alcohol. We are not getting alkene. Here we are not getting ether also. Alcohol and ether we are getting with the moist silver oxide alcohol, with the dry silver oxide ether. Okay. So here both are ruled out, and among alkene and alkane we will get alkane only because zinc in HCl is a reducing agent. Okay. Now let us move on to the next question. Next question here, isocyanide. Isocyanide is formed as the major product when the alkyl halide is treated with one of the following. When you are getting isocyanide, so first let us see what is isocyanide. Isocyanide means here NC. So actually we know that CN is cyanide, right? CN is what? Cyanide. Cyanide functional group. But NC is isocyanide. NC is isocyanide. Isocyanide. Okay, ma. So here, which option is giving us isocyanide? See here. So AgNO2, here it is the nitro group. So that's why this is wrong answer because we want cyanide group. Here also in the second option, KNO2. So we don't want nitro groups. So KNO2 is also wrong answer. Now look at third option, silver cyanide and KCN, which is giving us isocyanide. So isocyanide will be formed on AgCN and KCN will give you cyanides. Okay, Nama. So here AgCN is giving you isocyanide. So that is NC. Okay, ma. Okay. So how the reaction is there? Just we'll look at here. So alkanes, alkyl halide plus silver cyanide. Okay, AgCN. It will give rise to alkyl isocyanide. Alkyl isocyanide plus AgX. So this is the answer. So we are getting isocyanide when we are treating with AgCN. So hence our option is third one. Third is the right answer. Okay, ma. But KCN, once we'll try with KCN also. Let us see here. So Rx plus KCN. Okay. So when you are writing like this, here instead of NC, we'll get CN only. Simply, see here. Simply only cyanide is substituted. Okay. So cyanide, only this cyanide will be substituted in place of X. Remaining all same. So RCN KX. So we'll get here KX as the byproduct. So that's why KCN is not right answer because it is giving you cyanide, but AgCN is the right answer because it is giving us isocyanides. Okay, ma. Yes, let us move on to the next question. Yes, here what is the correct order of reactivity towards nucleophilic substitution reaction, ma? So what is the correct order for nucleophilic substitution reaction? Let us see. Okay, so here when you are looking at nucleophilic substitution reaction, we'll take another color, ma. Yes. See here. So in the first option, here we are having the alkyl halides. Okay. So first is fluorine, second is chlorine. Okay. And third one is bromine, and fourth one is iodide. When you look at here, because fluorine is the smaller in size, that is the order alkyl fluoride, alkyl bromide, and alkyl iodide. So for nucleophilic substitution reaction, larger is the size, greater is the reactivity. So in all these, which is the larger size? Iodine. So in this option, we should select iodine as the larger size. Then after iodine, which option you will get? After iodine, bromine, then chlorine, then fluorine. Okay. So already in your halogens, we are having fluorine, chlorine, bromine, and iodine. So for a nucleophilic substitution reaction to occur, the size should be more. As the size is increasing, the reactivity of that reagent will be increasing. Hence, our right answer is second one. Second is the right answer. So we got the answer as second one. So answer is 2. Okay. Let us move on to the other next question here. Yes. So next question here comes ethyl alcohol. So ethyl alcohol, when you are treating with PCl5, in the presence of PCl5, what you are getting? Already just now I told that when alcohols are reacting with PCl5, you will get alkyl halide. So simply just we'll try here. C2H5, C2H5OH. So this is alcohol. Alcohol, when you are treating with PCl5, it will give rise to alkyl halide, C2H5. Instead of here we got OH na, so instead of OH I'll get here X, so that may be here Cl. Okay ma. So then next you'll get, because we are using PCl5 na, we'll get a byproduct POCl3. POCl3 is the byproduct. Then remaining HX will be formed. So that is HCl. Here we are taking chlorine. So the X will be here chlorine only. So here we should see here in the question they are asking you alcohol on reaction with PCl5, they are giving you X. So what is this X? What is the X here? The major product. Okay ma. So the major product here is C2H5. This is 5 ma. Okay. C2H5X. This is our product X. So C2H5 is ethyl chloride. So let us see here where is the option. So first one is the option. So first one, ethanol. Second option is chloride, ethylene chloride, but that is ethylene. So second option is also wrong. So first one, anyhow alcohol you'll not get because it is ethylene chloride. Second option is also wrong. Then third option, ethylene chloride. This is also wrong because double bond is not there here. Only alkyl. So ethyl chloride. Here we are having in the fourth option. So fourth option, ethyl chloride is there. That's why our answer is 4. Okay. So the option, our right answer is ethyl chloride. Right. Now let us move on to the others. Next question, ma. Yes. Next question here is, what is X? What is X in the following reaction? That is C2H5Cl. Okay. C2H5Cl. On reacting with X, it is giving you C2H5OH plus KCl. So from alkyl halides, I should get alcohol. So alcohol, when you'll get means mostly The option should be either alcoholic KOH or aqueous KOH. Okay, so alcoholic KOH or aqueous KOH. When you are treating with the aqueous KOH, alkyl halides on treatment with the aqueous KOH, they'll give you alcohol. So let us see that reaction here. So alcoholic KOH will not give you alcohol, they'll give you ether. So that's why we are taking the aqueous KOH. So let us see the reaction here. C2H5Cl plus aqueous KOH. Aqueous, that means moist KOH you are taking. Okay, in the presence of water, aqueous KOH when you are taking, it will give rise to simply this chlorine will be substituted by OH. So that means I will get C2H5OH. C2H5OH is the right answer. Okay, plus KCl. So here this is your X. So in the question they gave you now, what is X? X means aqueous KOH. So in the options, where is that answer? Yes, here. Aqueous KOH. This is our right answer. Hence the answer is 3. Aqueous KOH. Okay, ma. So there is the answer. Let us move on to the next slide. Next question. In the sequence, what is X? In this following sequence, what is X? See here, in this example, they gave you, alkyl halide and KCN. When they are reacting in the presence of alcohol, they are giving you compound X. Already just now I told you, whenever you are having CN means, what is the functional group? That is CN means cyanide functional group. CN means cyanide functional group. So just now I told you, when alkyl halides are treated with cyanides, they'll give you alkyl cyanides. Okay. So with the KCN, it will give you alkyl cyanide. With AgCN, it will give you isocyanide, alkyl isocyanide. So let us see the reaction here. So once you'll see here in the options also, C2H5. So instead of this chlorine, I should substitute with the CN. So here, I should substitute with CN. So here, first option is the right answer. So CN is the right. So yes. So answer is CN. So that is answer is first one. First option. Okay. So that is C2H5O CN. Okay. So that is ethyl cyanide. And what is this NC? This is called as isocyanide. Isocyanide. NC is isocyanide. Okay, ma. So here, in the second option, isocyanide is there. That's why it is wrong. C2H5OH, alcohol, because in the reactant only, there is no OH group. So alcohol also will not get. Yes. Ether. When you will get ether, this is C2H8O. So that means CH3. Okay. And O. CH3. Sorry, ma, this is not H8, C2H6O. So this is CH3. So here CH3O, CH3O is an ether. So ether when you'll get only in the presence of moist silver oxide. Just now I told you, moist silver oxide, you are getting ether. Sorry, dry ether. Dry silver oxide. We'll get for dry silver oxide, we'll get ether. For moist silver oxide, we'll get alcohol. So fourth answer is also wrong. Only the first one will be the right answer. That's why in the preparation of the alkyl cyanides, when alkyl halides are treated with potassium cyanide, they'll give you ethyl cyanide. That is the first answer. Yes. Next, we'll move on to the next question, ma'am. Yes, 13th question. See here, with the zinc copper couple, with zinc copper couple and C2H5OH, ethyl iodide C2H5I reacts to give what is the answer? They are asking you ethers. Okay. Ethers. Ethers means R O R. R O R is ether. Okay, ma. And diethyl ether means C2H5. C2H5 is ethyl. Okay, this is ethyl. And in between oxygen, again, one more ethyl group, C2H5. One more ethyl group, C2H5. C2H5. Okay. So here, this is diethyl ether. Okay. Then next, third option is iodoform. What is iodoform? CH3, CHI3. CHI3 is iodoform. Then what is next one? Ethane. Okay. So next one is ethane. That is C2H6. Okay. So here, when you are getting this from ethyl alcohol, when you are treating with the alkyl halide, in the presence of zinc copper couple, it will give us ethane because zinc copper couple, it is a reducing agent. So let us try this reaction here. So C2H5OH, C2H5OH, when it is reacting with C2H5I, C2H5I, it will give us alkane, only alkane. So it will not produce any other ethers or iodoform. So that's why our answer is 4. Answer is 4. Alkane you will get. Okay, ma'am. Next, we will move on to the 14th question. What is the absolute configuration of a molecule which changes during the reaction? So here we are having SN1 reaction, SN2 reaction, free radical substitution reaction. Then next is SE2 reaction. SN1 is unimolecular reaction, only one molecule, and it will occur in 2 steps. 2 steps. Okay, Nama. So, and if you take SN2 reaction, it is a bimolecular reaction and it will occur in a single step, one step only. Bimolecular reaction, it will occur in a single step. And free radical substitution means, suppose if I am taking here CH3 and another CH, means there is a bond. So a bond means 2 electrons. 2 electrons will form a bond. If I am breaking this bond means 1 electron to carbon, see here, and another electron for hydrogen is there. So an atom with free electron is known as free radical. An atom with free electron is known as free radical. So free radical also will not take place. Only configuration. Configuration will be changing only during SN2 reaction because the nucleophile is leaving from the front side and the incoming nucleophile is attacking from the back side. That's why there is inversion of configuration in SN2 reactions. Okay, ma. So that is the 14th question. Then next, let us see about the 15th question. What is SN2 reaction? SN2 reaction leads to inversion of configuration. Just now we have studied. Okay. SN2 reaction leads to inversion of configuration. Let us see that. See here. So inversion of configuration means, suppose I am taking here alkyl halide. Alkyl halide I am taking. Okay. So this bromide is leaving from front side. It is a nucleophile, and OH. OH is another nucleophile. OH is another nucleophile which is attacking from the back side in this manner, attacking the carbon from the back side. So that means here, if you are taking carbon with three hydrogens, so here the the newly attacking group OH is there and the leaving group Br is there. So this is the transition statement. So after leaving of this group, see here bromine was present on the front side of the carbon. After leaving of this group, once you see at OH, it is present at the back side. So that means totally the configuration is changed. It is opposite. So that's why inversion of configuration. It will occur. It will lead to inversion of configuration. So it will lead to inversion of configuration. So our option is first one. Answer is first one. So this is inversion of configuration. Okay, ma. So now let us see about the next question in alkyl halide. Okay. So today we'll end this class here, ma. So tomorrow we'll continue. Okay, ma.